Hello students. Now in this video we are going to look about the two-way ANOVA. That is, I had already explained what one-way ANOVA is, and you know the difference between one-way ANOVA and the two-way ANOVA. Okay, one-way ANOVA is when any given data is collected only with reference to any one factor. Okay, and two-way ANOVA when the uh, changes are seen or they are studied with respect to any two vectors. Okay, it is a two-way ANOVA problem. So now let's see one example here. Suppose five doctors each test five different treatments for a certain disease and observe that the number of days each patient takes to recover. The results are given in the table. Discuss the difference between the doctors and the treatments. Okay. Now let's see. Let's see this table. Now in this table, here the doctors. Five doctors are listed. That is A, B, C, D, E are the five different doctors, and they use these five different treatments, five different types of treatments: treatment 1, treatment 2, treatment 3, treatment 4, and treatment 5. And these numbers are the number of days the patient requires to recover. Okay, that is, if a doctor A uses this treatment 1, the patient takes 10 days to recover. If doctor B uses this treatment 1, then a patient takes 11 days to recover. Okay, now my question is about whether there is a difference between the doctors, or there is a treatment difference between the treatments, or there is a difference between doctors as well as treatments. Okay, so now suppose if the question was only about like this. Now see, the question is what? Discuss the difference between doctors and the treatments. Okay, now if the question was only like this, discuss the difference between the doctors, or discuss the difference between the treatments, any one of these questions was there, and the same table would have given it was a one way ANOVA. That is, either the difference between the doctors has to be checked, or the difference between the treatments has to be checked. Okay, so such kind of question is a one way ANOVA, and you know how to solve it. Now, when both of these things are asked, that is, these are the two factors. See, the recovery of the patient is a variable. Okay, and that recovery period is affected by either the doctors or the treatments. That is, these are the two factors. Doctors is a one factor, and treatment is the type of treatment is the another factor. Therefore, it's a two-way. So now one of the method which is quite lengthy, which I had expected that you will be able to solve, is that uh, firstly keeping the doctor's term as it is, and treating this that only you need to calculate the difference between the treatments. Okay, whether there is a difference between the doctors or not, it doesn't matter. You have to only calculate about the treatments. Okay, that means it is a one way ANOVA. That means you will be able to solve it as it is. Okay, that is one way. By one way ANOVA you have to conclude whether these treatments do differ significantly or not. Okay, so with that, using that one way ANOVA, you will be able to conclude that about the treatments. Okay, that is one part. Now second part is about the doctors. Now what you could have done, now see, these treatments are listed in the forms of columns. Okay, and whenever we have, that is like the five samples, the sample, these five types of samples are being collected. Okay, that is how we have studied about a one way ANOVA. Okay, so for that, for checking for the doctors, what we could have done is we could have shifted these doctors which have been listed in kind of rows. We could have changed these rows to the columns. That is what doctors are listed here, and the treatments are listed in terms of these columns. We would have taken these treatments here and the doctors in the place of treatments. That is what we would have interchanged the rows and the columns. So now this A, B, C, D, E are my rows, and 1, 2, 3, 4, 5 are my columns. So in place of that, what we would have done, 1, 2, 3, 4, 5 we would have made as rows, and A, B, C, D, E we would have made columns. And now we could have solved it using a one way ANOVA. That is what, with that, what we will come to know, that is what is, whether there is a significant difference between the doctors or not. Okay, but now, okay, so with that we could have concluded whether there is a difference between the doctors and the treatments. But now this is a quite a lengthy method. Okay, now if it is coming for quite low marks or less marks, then one of the quite standard method we can use is, now see, or if the question is about like this, that find or discuss the difference between both two factors, then first thing what you can have done is, see, now this first thing is setting the null hypothesis and the alternate hypothesis, that there is no significant difference between the doctors and the treatments. So that is done, clear cut. So that will be your null hypothesis. Alternate hypothesis will be what? There is a significant difference between the doctors and their treatments. Okay. So now, next thing, now see, level of significance is also been mentioned. Okay. So now let's see, in this case, how many, five treatments in total and five doctors in total. Okay, so now these are my columns, 1 2 3 4 5 are my columns, a b c d e are my rows. Okay, now first thing what I will do is, I will sum up all. Okay, I will find the summation of all these columns and the summation of all these rows. Okay, so my summation of this will be 10 plus 14 plus 23 plus 18 plus 20 will be my row 1 value. Sorry, R1 value. 11 plus 15 plus 24 plus 17 plus 21 will give me my R2 value. Okay. Now, similarly, all these are 5 values. And similarly here, 10 plus 11 plus 9 plus 8 plus 12 will give me my C1 value here. Okay. So, similarly, we have formed this table. Okay, we have just added up those things, that is 10 plus 11 plus 9 plus 8 plus 12, that is total of column 1. Okay, that is C1 value, that comes to 50. Then the sum of all these values, that comes out to be 69. Sum of all these values, that comes out to be 103. All these sums. Okay, and similarly the sums across the rows. Okay, that is 10 plus 14 plus 23 plus 18 plus 20, that is my 85. And all such things we have got. Okay, that is just the summation of the values. This is across the columns, this is across the rows. Okay, now once this row, that is C row, total C row we have got. Okay, we have just squared it up. The square of 50 is 2500, square of 69 is 4761, and so on. Okay, similarly here, total R square column we have made, that is 85 square is 7225, 88 square is 7744. Okay, this is quite easy, just summing up the things and then writing the square. Now we need to write this grand sum, this G value, this column. Okay, now this grand sum, how it has come is, see, the sum of all these R values, that is this R column is there. Okay. Now the sum of all these values, that is 85 plus 88 plus 76 plus 75 plus 83, that comes out to be 407. Okay. So that is my grand total. Now, even if you check this column, that is 50 plus 69 plus 103 plus 83 plus 102, that also comes out to be 407. Okay, so that is the main thing in this two-way ANOVA, that you need to check that the sum of this all these columns plus the, sorry, sum of all these columns is equal to the sum of these rows. Okay, that is what this column summation and this column summation should be equal. Okay, and that is taken as our capital G, grand total. Okay, so yes, so this is how the table has been formed. Now, yes, H naught has, we have already said about H1, yes, level of significance, yes. Okay, now this R squares. Okay, now R square we have found, this can be treated as R1 square, this can be treated as R2 square, R3 square, R4 square, R5 square. Okay, now taking the sum of all this, that is what 7, I need to find the R square mean of R square. Okay, it will be what, this 7225 plus 7744 plus 5776, that is all this column added divided by the number of observations. How many observations are there in total? 1, 2, 3, 4, 5. 5. That is how many number of rows? 5 rows. So sum of all these divided by 5 will give me my R square mean. Okay. And similarly, so this is how we have found out. Okay. R square mean. That comes out to be 6651.8. Okay. That is the mean of this square. Now, similarly, this C square mean I want. Okay. So I'll take this row. I'll add up all these 5 numbers and divide it by again 5, since there are 5 number of observations. Okay. So this addition divided by 5 will give me C square mean. Okay. So that is also I have calculated to be 7032.6. Okay. So now till here the things are very easy. Now, next step is calculating this something called as correction factor. Now, this correction factor CF is given by G square upon N. G square we have seen grand total. G is grand total, that is 407. That is equal to 407. Yes, that is the sum of all the rows, which is also equal to sum of all the columns. Okay, so G square upon N is what? The total number of observations. Now in this case, the total number of observations are what? This. They are total 25 in number. Yes, there are 5 treatments and 5 doctors. So 5 into 5, 25. 25 observations in total. So I get my correction factor to be G square, 407 the whole square divided by N, that is 25, and I get it to be 6625.96. Okay, so this step is over. Now after that, this is just a formulas and you need to substitute. Okay, so now I have this um, formula, that is total sum of squares of all observations. Okay, that is TSS, the short form for TSS, total sum of squares. Okay, now it is given by total sum of squares of all observations minus this correction factor. Okay, now the students may tend to forget this subtracting this correction factor, but in every cases what you are calculating further, you need to subtract this correction factor from everything. Okay, so don't forget this minus CF value. Okay, so now how it is given? Total sum of squares of all observations. Now how it is calculated? All these sums, sorry, all these observations total, how many total observations are there? 25. So total you need to calculate all these squares, that is 10 square plus 14 square plus 23 square plus 18 square plus 20 square plus this 11 square plus 15 square plus 24 square plus 17 square till all this square, that is plus 22 square. So total 25 observations. Of all this you need to calculate the uh, squares. Okay, that is you need to calculate the sum of all these squares. Then from that you need to subtract this correction factor. Okay, that correction factor is 6625.96. Okay, so now the sum of all these squares comes out to be 7093 minus the 6625. So basically, after substitution you get this TSS value to be 467.04. Okay, now next step is calculating this SSR. That is what? Square sum of the squares across the rows. Okay, rows, how many rows? 5 rows are there. Okay, now for that, we, if you remember, we used to calculate that SSC and SSE in terms of one way ANOVA. Okay, now once this correction factor has been come into picture, this calculating those is quite easier in case of this two-way ANOVA. Okay, so it is quite similar. The concept is very similar. Only instead of making those big calculations, we take the shortcut in this two-way ANOVA. Okay, so SSR, this SSR, that is across the rows. Now that was SSC and C we would have treated as C. There is this SSC, that is across the control or the treatments. such things I had explained. Okay, that is SSC is across the columns. Now in this case, now it is across the rows and across the columns. So when it is SSR is across the rows now. So R square bar, this we have calculated, minus the correction factor. Okay, so R square bar we have calculated already here, 6651.8. Okay, that we will substitute. So minus the correction factor, this also we know, so that comes out to be 25.84. Okay, now next step is calculating SSC. Now how the formula will change? In place of R there will be C, that is what? SSC, the sum of the squares across the columns. So it will be C square bar minus correction factor. Now C square bar also we have calculated. Okay, that is here, this is the thing. Okay, so we'll just substitute it. So 66, sorry, here 7032.6 minus this correction factor, and that comes out to be 406.64. Now after this, calculating SSE. Now calculating SSE is given by this: TSS, the total sum of the squares of all observations, minus SSC minus SSR. We know all this, we have calculated all this. Okay, so this TSS is there, minus this SSR is there, minus this 406.6, this also it is the SSC. Okay, so when you subtract SSC and SSR from this TSS, you get this 34.56. Okay, now once all these things are done, we are making the table. Now how this table has been made? It's very similar to what we used to do in case of one-way ANOVA. Okay. Now source of variations, sum of the squares, DF is degree of freedom, mean sum of the squares, variance ratio F. Okay. So now see, first thing was we had only this much things. Other than this only two rows used to be there in case of one-way ANOVA. Now one more, since two factors are there are one more row has been added. Okay, now let's see factor A. Factor A is what? In terms of rows, I have just mentioned, named them as A. Okay, now across the rows. Now across the rows means what? In case of rows, what were the things? The doctors are there. Okay, across the rows, the difference between the doctors. So we are check for this, factor A is the doctors and factor B is the column. Factor B is the treatment. Okay, okay, so now factor A, SSR, that is, since across the it is across the rows, now everything will be in terms of rows. Okay, so now SSR. Okay, then here degree of freedom will be R minus 1. R is what? How many number of rows are there? How many rows are there total? There are 5 rows. Okay, 5 rows in the sense how many doctors are taken in consideration, that is 5 doctors have been taken in consideration. So degree of freedom is what? R minus 1, that is 4. Okay, 5 minus 1, 4. Similarly, this factor B is what? Columns, that is what? The treatments. Okay, so everything will be now in terms of columns, that is what? SSC, now sum of the squares across the columns. So that is we have calculated to be 406.64. Okay, and the degree of freedom will be again C minus 1. Now why C minus 1? C is number of columns minus 1. How many number of columns are there? 5. Okay, since 5 types of treatments were being considered, so 5 minus 1 is equals to 4. And the third one is error. Error is that SSE, sum of the squares of errors. Okay, now just a minute. Okay, so what was I saying is SSE. Now this is the sum of the squares of the errors. Okay, this SSE also we have calculated, that is 34.56 here. Okay, so now in case of that, the degree of freedom is, okay, just pay attention here. The degree of freedom in this case is this degree of freedom here into the degree of freedom here. That is the two degree of freedoms we have calculated, that is for factor A and factor B, that is 4 into 4, that will be the degree of freedom for this error. Okay, that is what now here we are combining the two things. Okay, now, so degree of freedom is done for this. Now mean sum of the squares. Now this, in this case, this column is given by sum of the squares column divided by this degree of freedom column. That is what here SSR divided by DF, that is degree of freedom, that is 25.84 divided by 4, that comes out to be 6.46. Then this SSC divided by, sorry, this one, that is 406.64 divided by 4, and similarly this SSE column, that is 34.56 divided by 60. Okay, so that is basically what this sum of the squares column divided by this degree of freedom column gives you this column. Now final step is variance, calculating this variance ratio. Okay, now variance ratio, it is given by what, this now for this factor A, what you will do is you will consider this SSR, the 6.46 divided by this error, that is 2.16, that is what factor A divided by this error, that is mean sum of square of factor A divided by this, so that gives you 6.46 divided by 2.16, that is 2.99. And the next is, for this you will get this 101.66 divided by 2.16. Okay, that is this divided by this will give you these two different things. So if you notice, there is no direct calculation between this factor A and factor B. Okay, that is what we have calculated some another totally different term, that is error term, and we have compared factor A separately with that error and factor B separately. Okay, so that is the reason this this two-way ANOVA can be converted into a one-way ANOVA and can be solved. Okay, so basically now what we are going to do is, now this is the F value, the calculated F value, this 2.99 is the calculated F value for this factor A, that is the doctors, and this 47.06 is the calculated F value for the treatments, that is across the columns. Okay, so now what we will do is, once the calculated F value has been found, next step is comparing it with the tabulated F value. Now the tabulated F value has been already given to us. Okay, now the tabulated F value is what, yes, 3.01. It has been mentioned in the question. The tabulated F value for the 4 and 16 degree of freedom is 3.01. Yes, now 4 and 16 degree of freedom. Okay, I'll explain the meaning of this. 4 and 16 degree of freedom is, now see, let's see for this factor A. Factor A has degree of freedom 4, and it is compared with this error term. Okay, that is 16. So if we compare this together, it is 4 comma 16. Okay, since as I said, this factor A in combination with this error has been calculated. Okay, so 4, that's why 4 comma 16. So that's why the value is 3.01. Now the 3.01 is greater than this 2.99. Okay, that is what, the calculated value is less than the tabulated value. That means what, my null hypothesis is accepted. Now for the factor A, what was my null hypothesis? The null hypothesis was that there is no significant difference between the doctors. Okay, factor A, there is no significant difference due to the factor A. Now what is the factor A? The factor A is the doctors. That means what, there is no significant difference between the doctors. Okay, now next, so this is the one thing. So about the factor A, the things have been finished. Now the second step is for the factor B. Now what is my factor B? It is the treatments. I need to check whether there is a difference between the treatments or not. Okay, now again for this, the degree of freedom is 4 comma 16. Okay, again 4 comma 16. If there was any other number in place of this, for the another value we would have got. Okay, now again for this the tabulated value is what? Same, 3.01. Now 3.01 is less than this 47.06. That is what the calculated value is less than the, sorry, calculated value is higher than the tabulated value. That is what the null hypothesis is rejected. Okay, now null hypothesis for this factor B is rejected. Now what is the null hypothesis for factor B? Factor B is about the treatments. So null hypothesis with the respect to treatments was what? That the treatments are same. Okay, or there is no significant difference between the treatments, but it is rejected. That means what? There is a significant difference between the treatments. Okay, so that is what final conclusion is, what there is no significant difference between the doctors, but there is a significant, sorry, but there is a significant difference between the treatments. Okay, so this will be your, yes, this is the final conclusion. Doctors do not differ significantly, but yes, the treatments differ. Okay, this will be your final conclusion. Yes, now in place of this 4. Okay, yes, now if you see in the question, the tabulated value f for 4 comma 16 degree of freedom is given. Okay, 4 comma 16 degree of freedom. Now if there was any other number like this, which we would have got, okay, suppose see my there were more number of columns, and if it's a degree of freedom for something, we would have got to be 5. Okay, and obviously this would have changed. Let's say for this would have changed. Then what we would have got, we would have, now there are two different degrees of freedom. Earlier it was like what, 4 comma 16 and 4 comma 16. Okay, but now they are like what, 4 comma 20 and 5 comma 20. Okay, so in such cases what you will have to do is, obviously two values, different f values will be given in the question. Okay, that is 4, a tabulated value of f for the degree of freedom 4 comma 20 will be given, and another value will be given for the 5 comma 20. Okay, so what you will do is, you will compare this 2.99 with the 4 comma 20 value, and you will compare this 47.06 with the 5 comma 20 value. Okay, so this is one of the method which you can use, okay, for this two-way ANOVA. Or as I said, compare comparing this, both the, both the comparing this both the factors as per this, using the ANOVA. One way ANOVA can be also done. Okay, that is applying one way ANOVA twice for two different factors, that can be also used to solve such kind of problems. Also, I would say that there are very low chances of such kind of problems appearing in the exam. Rather, I would say a very hardly less than 5% chance of the appearing into the exam. Okay, most stress you should give on one way ANOVA.